So there was no intro in the last video on constant of proportionality, so this one is kind of going to tell you what you need to know from both videos. From the last video, you should have walked away with the ability to determine whether a relationship is proportional or not. And if it is proportional, you should be able to tell what the constant of proportionality is and write an equation that shows the proportional relationship. If it's not proportional, you should be able to determine why the equation represents a relationship that's not proportional. From this video, you should be able to be given a graph. From that graph, you should be able to tell whether a relationship is proportional or not and explain why. You should be able to take that graph and create a data table. And you should be able to take the graph and be able to write an equation that represents a proportional relationship if in fact the relationship is proportional. You should be able to figure out the constant of proportionality from a graph, from an equation, and from a data table. Please enjoy. So if I look at this graph, which is the amount of water in a pool, and the relationship is between the number of gallons in the pool and the number of minutes it takes to fill up the pool. This is a graph of the data table that you saw in the last video. So graphs of proportional relationships have three qualities that you need to remember. One, they have to be straight lines. So the minute you see a graph that's not a straight line, then that relationship is no longer proportional. It has to pass through 0, 0. So 0, 0 is that point right there. And if you think about a true coordinate plane that has 4 different quadrants, right, it would have to pass through 0, 0. What we're looking at here is only that quadrant, called quadrant 1. So when you were just looking at one quadrant, it's going to end up starting at 0, 0. But if you were to look at a coordinate plane, an entire x, y axes, it would have to go through the origin. And the origin is 0, 0, where x is 0 and y is 0. So it must be a straight line. It must pass through 0, 0. And it must have a value on the graph that is represented by x is 1 and y is the constant of proportionality. So if we were to look at when x is 1, okay, in that case y is 10. So you can say that the constant of proportionality in this case is 10, because if you look at the value of x when x is 1, if you look at the value of y, that's going to give you your constant of proportionality. And if you match up the other points, you'll get all of the other relationships. So in this case, if you were to create an XY chart, we already know 0, 0 is on it, and we know that the constant of proportionality is when x is 1, and we can then follow when x is 2, y is 20, and when x is 3, y is 30, and so on. So that data table that you saw in the last video is represented by this graph. When you look at just the graph and you don't have a data table, what you have to be thinking to yourself when asked if it's a proportional relationship is, does it pass through 0, 0? Is it a straight line? And is the point 1, the constant of proportionality, is that point on the graph? So if I look at this graph, that's the cost of roses. On my x-axis, I have the number of roses, and on my y-axis, I have the cost in dollars. So if I'm asked if this graph shows a proportional relationship, the first thing I'm going to check is that it's a straight line, which is correct. It's a straight line. Does it start at 0, 0, or does it pass through 0, 0? Yeah, right there, 0, 0 is on my line. So when I'm creating my data table, that should be an X, so it looks funky. I know that 0, 0 is part of it. And then 3 is my constant of proportionality, where x is 1. So if I look here, x is 1. When x is 1, y is 2. So that means that for 1 rose, it costs $2. For 2 roses, it costs $4. For 3 roses, it costs $6. And for 4 roses, it costs $8. So what I can say to myself is, yeah, it appears to me that there is a constant of proportionality, because the number of roses is 2 times the cost per rose is 2 times the number of roses. So in that case, what that means to me is each rose is $2. So is there a constant of proportionality? My answer is yes, there is. And the constant of proportionality in this case, k equals 2, because 2 over 1 is the same as 4 over 2. is the same as 6 over 3 is the same as 8 over 4. So the relationship between cost and rows will always reduce to $2 per rows. And what's the equation for this relationship? It would be the cost per rows equals 2 times the number of roses, or y equals 2x. So just by looking at a graph, I'm able to tell, yes, it's a proportional relationship because it passes through 0, 0. It is a straight line, and it does have the value of x matched up with a constant of proportionality of 2, otherwise known as 1 comma k. It does have a proportional relationship of k equals 2. So I can figure out my proportional relationship. I can create a data table just by looking at a graph. So I can go from graph to data table, and I can create an equation. And this equation will let me figure out if I buy 150 roses, I'm going to be spending $300 because I'm going to be multiplying 150 by 2.